So welcome to the Sedona Community Office Hour of July this year. My name is Jia. I'm the PMC chair of Apache Sedona. And as usual, let's give a quick overview about what Sedona is and also the status of the Sedona project itself. So as you know, Sedona is an open source cluster computing engine for processing large-scale geospatial data. It is the most popular open source engine for scalable spatial compute. We have our website, sedona.apache.org. We also have our GitHub account under the Apache organization. We also have our accounts on social media, on X and LinkedIn. And if you want to talk to the fellow community members, we also have a Discord server. So if you want to have like live chat, so feel free to join us on Discord. We have multiple Sedona PMC members and committers there to answer your questions. Cool, let's move on. So the status of Sedona. So as you see on the right, so Sedona actually is being used by many companies in production. So it actually a project we started about 10 years ago, and it became mature in 2017 and joined Apache Software Foundation in 2020. And it has over 10,000 corporate users, and right now it has 145 contributors on GitHub, and it has 2.1 thousand stars on GitHub. And each month it has over 2 million downloads, and its overall downloads have exceeded 48 millions. So this actually placed Sedona among the top 0.3% most downloaded package on PyPy. And here is an overview about the Sedona system architecture. So as you see the diagram on your right, so Sedona has multiple layers. So the top layer is we call a spatial query processing layer. So this layer actually integrates with several popular developer tools, such as Apache Zeppelin, Tableau, Jupyter Notebook, GeoPandas RStudio, so on and so forth. You can actually use Sedona in all these kind of developer tools and run your query, spatial analysis query at scale. And in the query processing layer, it also equipped with multiple APIs, Spatial SQL, Python, Scala, Java, as well as R. And it also equipped with a bunch of distributed query algorithm, so which actually give a spatial SQL query. So Sedona will actually distribute the workload across machines in the cluster. It also has a spatial query optimizer. So give a spatial query, it can analyze the spatial characteristics of the input datasets and determine which query algorithm is the best, is the optimal one for this particular query. And the second layer is what we call distributed spatial dataset layer. So it has multiple things involved, including spatial partitioning, spatial indexing, so on and so forth. And the bottom layer is the distributed engine layer. So Sedona can actually run on top of a number of engines, including Apache Spark for batch data processing and Apache Flink for stream data processing, as well as on Snowflake. So among all these engines, so our support on Apache Spark by far is the most comprehensive one. And the easiest way to get started with Sedona is actually through our Docker image. Sedona has an official Docker account on Docker Hub. It is also under the Apache Software Foundation. And you can do a Docker pull to pull the latest image from Sedona. And after that, you can also start to run Docker image. What it gives you is a Docker image that has a Jupyter Notebook built in. Also, it has a Zeppelin notebook server also set up, so you can choose either to run write Jupyter Notebook in Jupyter Lab environment, or write a Zeppelin notebook. So Sedona also follows the 3 month release cadence. We have made multiple release this year. So the latest release we made was last month in June, and on June 7th, it is Sedona 172. So Sedona 172 is a bug-only release. So it is also the final release for Java 8. And we plan to, as you see that, although we try to follow the 3 month release cadence, Sedona 180 probably will be out in around July. So because Sedona 180 is sort of a special release, so this release is supposed to have support for Spark 4.0, right? And so this is sort of a special release that is does not follow the specific release cadence. Oh, so as I mentioned, so in the release we made last month, so it is a bug fix only release, and so you can check the release notes. I won't reiterate all the bug fixes covered in that release, but if the bugs, if you run into any of those bugs, make sure you update to 7.172. In general, so I always encourage our users to always upgrade to the latest bug fix release. Okay, so in the upcoming release, which is Sedona 180, we have many exciting features, right? So the first thing and the most important one is the Java 11 support, and as well as Spark 4.0 support, and PyFlink support, as well as a new ST transform algorithm and geography types, as well as GeoPandas API on Sedona. So let's start with the Java 11 support. So why do we need to do Java 11? So many of you already noticed that. So Java 8 has been a very, very old Java version, and there are many, many libraries they have moved on from Java 8, right? But in the past, the problem is most of our Sedona users running Sedona on hosted service, right? On EMR, Databricks, and the other engines. It is really hard for us to provide a version that is not able to be compatible with the other platforms. So there are several motivations for us to use the latest to use Java 11 and move away from Java 8. So first of all, so it allows us to use the latest versions of underlying dependencies. So this actually allows us to use, for example, the latest version of GeoTools, which we use GeoTools in many places for raster data processing, and also allows us to use to integrate with Apache SIS for better ST transform performance. And in the upcoming release, Apache SIS and GeoTools, they will be able to coexist in the same project. So in the past, GeoTools use a class path that actually is conflicting with the namespace with Apache SIS. They have solved this problem in GeoTools version, I believe, older than GeoTools 30, I think. And also Sedona Snow, which is the plugin we have for Sedona on Snowflake, it must use GeoTools older than 28 because of a security problem. And the GeoTools 28, GeoTools older than 28 use Java 11 by default. So we expect this to have very minimal impact on the downstream users, but I still want to point it out, right? So first of all, based on our investigation, all major Spark hosting services have at least one LTS version on Java 11. So that means Databricks runtime 16.4, it has a LTS version, and it has Java 11 enabled by default. And AWS Glue 5.0, it is using Java 17, and EMR 7.x plus use Java 17, and the Microsoft Fabric starting from version 1.2 that was a while ago, it starting use Java 11, and the Google Data Product Spark, it used Java 11 from the very beginning. And Snowflake Java have been using Java 11 starting from a few years ago, so we're also safe. And for Flink 2.0 has defaulted to Java 17, and Flink 2.0 has been out for quite some time. So that means Java 11 is really safe for us to use. All right, and so another important thing is that, as I mentioned, so is actually the Spark 4.0 support. So I don't have a slides for that today, but if you look at if you follow the Sedona GitHub repository, so the Spark 4.0 support PR has been merged a few days ago. So we plan to release that, as I mentioned, make the release really soon this month, right? So you'll be able to see the benefits and start to use Sedona with Spark 4.0 directly. So another feature we want to introduce in Sedona 1.8 is the PyFlink support. So if you're a Flink user, you should be able now to create a Sedona context in Python with PyFlink. So this includes basically gives you the SQL environment that allows you to plug in spatial SQL queries in Flink, in PyFlink, and together in the Python environment. All right. Another very cool feature is the better ST transform support. So just for folks who are not familiar with the ST transform in Sedona, or ST transform in general, like in PostGIS, right? So basically, ST transform takes three inputs. So the first input is the geometry, and then a source EPSG code, and the target EPSG code. So what it does is it tries to reproject the coordinate systems, the coordinates of the input geometry from the source CRS to the target CRS. So CRS here means coordinate reference system. So basically this helps you to like for example, in many cases that if you probably are using the WGS84, the EPSG 4328 for the longitude and latitude, right? But sometimes if you want to plot that on a paper map or on Google Map, right? You want to reproject those coordinates to a planar map. So that in that case, you can also use ST transform for that, right? So the ST transform implementation in Sedona, it was using GeoTools for the ST transform for the transformation algorithm. Of course, we had some internal tools to sort of speed up the performance, but there were issues with that. And now in the new release, we will move that to using to use Apache SAS ST transform algorithm. And the benefits is to use Apache SAS. It's going to give you better accuracy with also similar performance. Another actual side benefit I forgot to mention here is it's going to also help us to get rid of the licensing issues with GeoTools. So if you guys use Sedona in the past, you'll probably notice that. So there are, in addition to the main Sedona jar, right? So there is another jar called GeoTools wrapper, right? So the reason why we have a separate GeoTools wrapper is because of the licensing issue, because the license of GeoTools is not 100 compatible with Apache SAS. But don't worry. So the license of GeoTools is still allows for commercial use, but the problem with GeoTools license is it has some additional minor requirement. So you can take a look, but that actually stop us from bundling that into Apache Sedona. So with this with Apache SAS, so we'll be able to put many of those to sort of like reduce our to help us like less reliable, less depending on the geo tools. So just to give you a little bit more background about the ST transform, right? So in many cases, transforming large data set can be really computational intensive for ST transform. This is because there are some very complicated CRS requires complex data shift, right? So what is datum? So, so a geodetic datum is a reference frame that defines the size, shape, and orientation of the Earth, right? And a datum shift occurs because different datums have slightly different reference ellipsoids and or different definition of of the Earth. So this happens in many cases. So for example, so especially when you have two very different CRS, right, from the NAD 27 to NAD 83. And also, if you want to reproject, use ST transform to reproject any local national datum to WGS 84, right, you will have this kind of complex datum shift. So this is going to be really, really computationally expensive. And also oftentimes it requires, if it is not uh, 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 being taken care properly, so it's gonna give you accuracy loss. And Apache SAS did a pretty good job on that. So that's also another reason we want to use Apache SAS on that. Cool. Another exciting features in Sedona 1.8 is actually our geography operators. This still it is a work in progress. So once this become more mature, I will invite a Sedona PMC member to talk about this project and give you a better understanding about the progress. Okay, to hear it, I'm just giving you a overall introduction about about that. So as you probably already know, right, from the very beginning, Sedona support geometry type, which work with coordinates on Euclidean planar space. And the problem with geospatial data is many of them, they're actually geography data. So meaning that, so there are coordinates on the Earth's surface, right? So this introduces problem. So especially when it comes to calculating the spheral distance between 2 points, like from New York to Beijing, right? So the distance calculation needs to take into account the spherical shape of the planet, right? And also, it also need to consider the anti-meridian crossing geometries. So if it is not taken care properly, so this is going to lead to wrong results. So we have made a couple attempts in the past in Sedona to sort of mitigate the geography issues. So that's why we currently support several critical geography operators, although they are not comprehensive, but they solve the most critical use cases on top of the geometry data type. So that includes STDVZ with spheral parameters and the ST buffer, ST distance sphere, and the ST distance spheral. So all these functions should be able to help you with the distance calculation for a spherical shape, right? But what we ultimately want in Sedona is a geography data type. So if you guys follow the Sedona GitHub repository, so actually in Sedona 1.171, we actually added a geography data type, although we didn't uh, explicitly mention the geography data type in our documentation because it is still a work in progress, right? But that's the ultimate goal. We added a geography data type in Sedona 171, but we didn't introduce any operators, any functions, ST functions for the geography data type. So now in currently in Sedona GitHub repository, we actually started to add operators, ST functions for the geography data type. So the overall idea of the geography data type and operators is that, so this is going to be based on top of Google S2 library, right? And the spherical mode. So it assumes the Earth is a perfect sphere shape. And based on that, we can do the math. And first of all, because we don't have, because Google S2 is just a pure indexing system that calculates the index for given point or polygon, right? It is not a library that can perform, for example, intersection, touching, contains these kind of operators, right? So we are actually working on a Java-based basic geography library called S2 Geography Java, right? So we're gonna build a Java-based geography library on top of S2 inside Sedona. So we have a couple PRs open already to support this. And after that is done, right? We're gonna introduce that. We're gonna introduce the ST functions built on top to rely on the S2 Geography Java. And in this library, we can also introduce a few. We're going to basically follow the OGC simple feature operators, the most common ST function that you are familiar with. We're going to continue to build these functions throughout the Java 1.8 series, right? So we're going to release some of the operators in Java in Sedona 1.8, and some of them are going to be also released in Sedona 1.81, 1.82, so on and so forth, right? So yeah, so this is another very exciting features. Cool. There's another very interesting project going on that's going to be released in Sedona 1.8 is the GeoPandas API on Sedona. So for that, I'd like to invite Sedona committer Feng Zhang to give a presentation to talk about the overview and the milestone of this project. Feng, please take over.
Sure. Thanks, Jia. So let me share my screen. Great. Okay, give me 1 second. Cool. All right. Hello, everyone. My name is Feng Zhang. I'm a Sedona committer. I've been working on a few features, including KN join, UDF function improvement, ST reader, and more recently, this GeoPandas API on Sedona. So I'm going to spend maybe 10 minutes to talk about this new feature that we plan to kind of release on 1.8 very soon. I mean, hopefully at the end of this month. So first, what's the goal of this project? It's really, I mean, the goal is actually very simple. We're trying to implement GeoPandas function on Apache Sedona, which means our end users can, have a very minimal change to their GeoPandas code, but instead of running on a single machine, they can run on a distributed way by using Apache Sedona. So basically, it's kind of very similar to what people, if people already is very familiar with the pandas on Spark, this is a pretty similar to that approach. So just a little bit of history about how pandas on Spark has been invented in the past, the Spark community. So they started with a project called Colas. So it's a totally separate project outside Apache Spark. So they have the very similar goal. They want the pandas end users to be able to use their API, but running on top of Spark, right? Very, very similar. But it turns out to be a very popular feature that the Spark community decided to include that into the Spark directly. So it turns to be it was added to Spark as a package on PySpark. So nowadays, like a lot of people, especially on the scientific community, they kind of use this approach to scale their code with a very minimal change. Right? For us, I think we had the same idea. Like, can we, because we know there's a very big, geospatial community, especially for the scientists, they kind of use a GeoPandas Python package to do a lot of research, but sometimes, because their data set is too large, single machine GeoPandas cannot handle all this. So now, because we're trying to implement this new feature on Sedona, and after we release this, so they will be able to run their GeoPandas application directly on a Spark cluster, right? So here's a kind of example, like showing once this is released, how people will use that. As you can see in the code snippet, the common code is actually a normal way that people to import the GeoPandas as GPD, and then they can load a data frame from a shapefile. They can, assign some of the attribute to that data frame, and also they can, compute based on some UDF functions they can, available on the GeoPandas API. And with the Sedona GeoPandas API, they will be able to keep all this old code, but only change the import instead of importing from GeoPandas, they can just replace that with importing from Sedona GeoPandas, so they can keep all their code unchanged. So that's our goal. So we don't promise like 100% compatibility, but I think the first release will pretty much cover all the common case that people can use. Right. So I'll talk about that in a minute. So under the hood, so basically what happens is that our GeoPandas API, Sedona, basically is a wrapper on two things. One is the geo, right? So it added geometry column support on top of pandas, right? So that's actually the function like GeoPandas do, right? And then we also added the distributed way, which basically means under the hood, you can see here, we basically include a PySpark series as internal format for the Sedona Geo series, which basically means first people can run any Pandas API on top of on top of this, and also they can run any PySpark series on top of this. So we fully support that, and on top of that, we add our ST functions. We add spatial joins, and even the KN joins on top of this. So basically, this is like three levels: pandas, PySpark pandas, and the GeoPandas all together. Okay. Yeah, this is for the geo series, and we also, we did the same thing for geo data frames, but instead it was only having one geometry column. Now, for geo data frames, it will support multiple geometry columns there, but very similar. So basically, this project was kicked off like 3 months ago, I think early this year. So we have been doing some design work and also collect some feedback from the community, like how people want this to be. And we finished the framework in terms of coding, testing, and documentation. So those are already on our main branch, Sedona. And the second phase will be fully implement GeoSeries function. This is ongoing effort right now, and at the same time, we're trying to implement the geo data frame functions as well. So after these two, there's a few other very important features that we also want to include. This include the indexing support for both series and data frame, and some of the very important utility functions that GeoPandas provide. So this is like is under like very active development right now. So I would encourage everybody, if you are a developer, if you want to contribute to this work, please check out the Sedona source code, and I have a link here pointed to where the code currently is under Python Sedona GeoPandas package. It has unit test, it has the framework. I mean, if you want, you can just pick some of the util function to start to implement that. So we'll have someone to review that. And I also put some links to GeoPandas API itself and also Pandas on Spark. So there are like two most important dependencies that this API will use. Last I will thank to Gia for his support, along the way, and also Peter Newing, who very actively contribute to the project right now. So if you have any question, just let me know, or Gia or Peter. We're happy to have discussion and also help you to set up your development environment for this work. All right. Thanks, everybody. Is there any question I can answer? Okay, cool. All right, thanks, Gia. Back to you.
Yeah, thank you, Feng. All right, guys. Uh, as you know, so the Sedona community is always calling for help, right? So there are multiple ways that you can help Sedona. So that actually includes, for example, the GeoPandas API that actually needs your help. You can contribute new functions to that. And also we have notebook examples, and you can contribute new examples to that repository, and also update documentation website if you found any typos, right? And you can also participate in our release test. And we actually have a voting process for each release on Sedona mailing list. So that includes verify the bug fixes and also verify signatures, and also perform some basic correctness tests in Sedona. All right, I see there is one question. Okay, there's one question. So why GeoPandas API with Sedona would be better than GeoPandas plus Dusk? Uh, Feng, do you want to answer that? I can answer that as well.
Yeah, so I think I don't think I have a perfect answer to that, but my thinking is that basically this is a question like Dask versus Sedona, like right, like why people even use Sedona versus Dask. I think there's definitely some benefit of backing any API, including GeoPandas API with Sedona, because the spatial join, the KN join, also the scalability, the stability. I think there's certainly some benefit for using Sedona. So that's our goal. It's also I think our advantage for Sedona. Yeah, it is not specific for GeoPandas, but in general, Sedona versus Dask.
Yeah, so that's a very good answer. And another thing I also want to emphasize again, Feng already mentioned that in his presentation is, so the true Pandas API on Sedona, it still use Sedona internally. It is not using It is not using GeoPandas or Dask, right? It is still using Sedona internally. It just offers you with the same API of GeoPandas, so you can actually do lift and shift on your GeoPandas code. Okay. So another thing is that uh like as you probably already know, right? So we did lots of research and published a whole bunch of papers on the Sedona internals, right? So there is also a book of the design or O'Reilly book of the design of Apache Sedona. So if you guys don't know, so make sure uh like you take a look. So we have book for that. So we also talk about all the internals, including distributed spatial partitioning, distributed spatial drawing algorithm. So this part actually, especially when it comes to very complicated spatial drawing. So the distributed spatial drawing algorithm is not available in ordinary GeoPandas or GeoPandas on Dask, right? So they are sort of like totally different things. So Sedona is designed for large scale distributed geospatial workload from day one. Cool. So this another question. Okay. Well, there are okay. So there are many questions here. So let me see. Okay. So there's one from Matthew Powers. So will you be open sourcing Java S2 library and also Sedona ST functions for S2? Yes, the answer is yes. As I mentioned in my slides, right? So if you actually check Sedona GitHub repository right now, so we just have the first S2 geography Java library, Java PR merged in Sedona repository, right? So we're going to open source this S2 geography Java library, and also we're going to open source and continue to implement those ST functions for geography. So you'll be able to use all this ST function we had in the past on geography data type for spherical surface. Cool. So there's another question from Matt. Are there any built-ins for working with overture map data? Or do we need to use other tooling to download Parquet file from S3 and load into Sedona manually? Very good question. So I actually want to point out that so all the overture data, all the overture GeoParquet data, they were generated by Sedona. So that means you should be able to use Sedona to read Overture data immediately because the data was generated by Sedona. So Overture is a user of Apache Sedona. So uh, if you actually use, I'm not sure if you follow our notebook example. We do have one notebook example that is specific designed for the for reading Overture data. So let me see if I can find it or not. Yeah. Okay, so this is the one. Let me paste in the chat. Yeah, in the webinar chat, you should be able to see there's a link for a notebook, right? So this notebook is on Sedona repository. It actually shows you how to use Sedona to read GeoParquet data from Overture directly without actually downloading I mean, if you run an analysis on the GeoParquet data, you will have to download the data, but Sedona will actually perform the data fetching, data download itself, so you don't have to actually worry about that. And another important thing is Sedona gonna be able to doing data pruning or filter pushdown on the GeoParquet files. So it is really, really fast on downloading those Overture data. Oh, okay. There's another question from Matthew. So what is the difference between H3 and S2? Well, so there are lots of differences, right? So I won't get into the details, but in general, right? So it is very obvious that so S2 So H3 they are hexagons, right? So they are hexagon, and S2 they are like rectangles or like rectangle grids, right? But mathematically, right? So they have totally different design. So they have different design about how to cover the surface, right? So but they share the same idea. The same idea. The idea here is that they want to sort of have a for like have a whole bunch of grids that covers the entire surface of this spherical shape. So that's the idea. So they are hexagon grids, they are rectangle grids, right? And there's one thing that is really good uh, in Google S2 is that so S2 has global coverage of every single piece, right? So this is really, and H3 does not guarantee that it has global coverage, right? So S2 has global coverage, and in many cases, this is really good for us to perform, especially when it comes to spatial queries or spatial data processing for data that is not on the land. So, for example, like flight data, right, or any data that is in the ocean. So that is really good. That is something that is supported by S2. Cool. Another questions from Vivek. Does Sedona has a recommended cluster setup for high availability? Well, so there are many. So of course you can set up Sedona yourself with open source Apache Spark. You can host Sedona together with Apache Spark in your own cluster environment, and you can also have have Zookeeper to have a master group for your like uh, uh for the master node of the cluster. So that's definitely possible. And on the other hand, there are many Sedona users, they actually use managed or hosted Spark or Sedona service on the cloud. So that means the vendor actually takes care of the high availability problem. So there are variables that provides Sedona hosting services. There is Databricks, AWS EMR, right? So there are many of them. So I would recommend that if you are not familiar with Kubernetes, not familiar with the uh, Zookeeper, this kind of tools, right? So I would recommend that you use a hosted service for that. Cool. Uh, Another question. So ST buffer geodesic will be really useful. Yes. Yes. So ST buffer geodesic right now it is already available in Sedona, right? So although we want to have one that is more specific for the geography data type architecture, right? But that's the buffer with geodesic distance. It is already available in Sedona right now. Cool. There is okay another question from Matthew Powers. So, yes. So Google S2 library is in C++. So I guess that's why Java S2 library will be useful. So there are a couple of things. So the Google S2 library, it actually has C++ and the Java version as well, right? So they are all open source. They are on GitHub actually. There is Java version for that as well. But the issue with Google S2 is so it is just a spatial indexing system. So it just tells you how to use a bunch of grids to cover the entire surface of the planet. It does not tell you how to perform uh, uh, intersections, right? Perform spatial operations. More specifically, it does not give you the functions that you can run ST functions on top of that, like those kind of OGC simple features functions. So that's why we actually need another library that is built on top of Google S2, Google S2 Java, to actually add the support, geographic support, or the function support for ST functions, right? And it's gonna use the core mathematics from Google S2, but it needs to have additional mathematics functions to build those kind of simple feature as the intersects within, within, contains, right? All those functions, they are not actually available in Google S2. So we need to be we need to be building that ourselves. Cool. I think I answered all the questions in the chat. Please feel free to post new questions, or you can also raise your hand. I can open up the mic so you can talk. All right, guys. So one more thing I want to mention is, so we oftentimes do live stream about Sedona success stories, right? So if you are active Sedona users and would love to share your storage with your story with the public, right? Feel free to reach out to me, and we can have a webinar on LinkedIn, right? To talk about your story and talk about how you leverage Sedona to solve your uh, big geospatial data problem, right? So feel free to reach out to me, and you can also find me on Sedona Discord server. All right, I think that's going to be all for today, and thank you all for attending the office hour, and gonna see you next month. Bye.